So now we are really getting a little bit, after we dove a little bit in the old specs and standards and, details of IMAP, we are now going to hear a lot about JMAP. Sorry? Yeah? Yeah, sorry. We'll be talking about JMAP, which is a new set of standards that has been engineered in the last couple of years by some very engaged people that also in parallel have been contributing a lot to IMAP and still do. And we are very happy that we have one of these persons here, or a representative from FOSDEM, which has been a company very instrumental and putting a lot of effort in this new set of standards. And yeah, Rick, your stage is yours. We are happy to learn about JMAP.
All right. Applaud fast because I got a lot of slides and I got a little bit of time. So we're going to talk about JMAP. Funny story. I was pitched this talk where I was going to talk about JMAP. I'm like, what is it? How does it work? Why is it so great? How can you use it? How does FastMail use it? All this stuff. I covered everything. It was a really good talk. It was like an hour long. And then I looked at my email that I was coming here, and it said you get 15 minutes. And it had to be in PDF. So this is just like the absolute minimum .pdf of my slides. And if you want to hear the whole thing and see all the builds and all the animations and everything about IMAP and JMAP, that can be arranged very easily. Talk to me later. That's me. I work at FastMail. I'm not going to talk about myself. We don't have a lot of time. Let's talk about IMAP. Sorry. Who was here for the IMAP? What I wanted to know before I wrote IMAP library earlier. Okay. Well, you missed a lot of horror stories, but I'm going to give you some now. This is IMAP. And I'm going to be real brief about it. What you're seeing here is the server in white, the client in yellow. We log in. We says, yeah, you logged in. And now we select an inbox. OK, this is the IMAP protocol, very basic. But here's all the beginning of the parts of the grammar you need to parse. And it's a bunch. And if you were here earlier, you're going to see lots and lots and lots of more stuff. Weird literals, like weird ways the interaction with the server changes how you parse the response, synchronizing and non-synchronizing literals. It's a complicated protocol, and it's not like other protocols that you're using. And there's a really simple reason for that, which I'll get to. Oh, yeah, right. This is the protocol to do stuff, and then this is the payload of the message is MIME, which is like another thing nobody wants to deal with. It works great, and it pays my salary, but, I mean, say what you want about HTTP and JSON, but at least it's not this stuff, right? Like, you probably all know how to use HTTP, even if you don't know how it works under the hood. And you probably know how it works, because it's really nice and simple. So I had lots and lots and lots of slides talking about how weird IMAP is, and I would love to tell you about it. But I'm just going to tell you about this one thing, and this was touched on earlier. Blah, 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 blah. Server and client are talking, and eventually the client says, I want to mark message 12 deleted. Store the flag deleted onto that message. And the server says, great, you have fetched this information. And this is where people get really confused, and it comes down to something Arndt said earlier. The only way to understand IMAP is that IMAP is a cache invalidation protocol. It's a protocol that tells you what to do with your cache. So you've got a server, and you've got a client, and the client can send basically the commands you expect, like I want to fetch or update or create or delete messages. And the server's response is, in response to that, here is how you should update your cache. And if you don't think about IMAP that way, you're going to have a bad time. Everything works this way. If the client says, I want to work with the inbox, it says, select inbox. And the server says, there are 172 emails, and these flags exist, which is a way of saying, here's how to initialize your cache. When you say, I want to look at my new mail, the client says, fetch these things, and the server says, you've fetched these things, which means put these in your cache. When you say, I want to mark this mail red, you say, store this flag, and the client says, put this in your cache. That's how it all works, and you have to start by understanding that, even to understand JMAP. You won't have to talk much more about IMAP. OK, there is one more thing, though. This is another fairly basic IMAP conversation where we're saying we want to come up to date. And come up to date is really important. See, at the beginning, we say queue resync. That means we want to quickly resynchronize our IMAP storage offline. So we say queue resync, and that our client state is 123. Just tells what the state was the last time we synced. And we get told, great, your next sync is going to be 130. Here's all the changes to apply. And when you're done, you'll be at state 130. Without this, IMAP kind of sucks. I mean, it's better than POP. But one of the great things about it is you can synchronize, go offline, come back later, and quickly get up to date no matter what else has been going on. Okay. Now you understand IMAP. Good job, everybody. Yep. Who wants to go implement it? Oh, yeah. Yeah, like these 4 freaks. Okay. The good stuff is good, but the bad stuff sucks, and there's so much bad stuff. So, like, good stuff. You can resynchronize from a previous session. Great. You got a domain-specific model. IMAP is built around email. Really nice. How about the bad stuff? Okay, the data format sucks. The transport layer sucks. The code that's out there is not great, mostly. The key features of IMAP aren't in the core protocol sometimes, so you need to make sure you've got the right extensions loaded, the right capabilities available, or you're implementing to the worst common denominator. And there's way, way too many parentheses. Okay, so this is why we built JMAP. JMAP is the JSON Meta Access Protocol. It's just JMAP. It's IMAP plus 1,000, right? This is what it looks like. So already I hope people are feeling better. You know what this stuff is, right? We're posting a request. We're posting a request to the JMAP endpoint, and we say, I want to get these emails. Great, right? So it's just like everything else. It's a RESTful protocol, kind of. Here's what you get back in response. You said you wanted to get emails 1, 2, 3, 4. Here's one of the ones you might get. You did an email get. You're getting a list of messages. This one has ID 1, and there's its subject. There's more stuff. But it looks like this. You can parse this. Anybody knows what this means. Here's a bigger context of it. So you can see like there's an ID and there's parts of the body and the subject. But the thing I want to call your special attention to is it's got one simple date format. Yeah, I mean, you can stop there and it'd be a pretty good improvement on IMAP and IME. But we're going to keep going. Here's another thing. You can say, I want to get, when the server responds to you, it can say, yeah, you did just get these messages. And by the way, your email collection is at state 616. It's just like that queue resync thing. It's going to let you say later, I've got mail, and it's got it all up to state 616. Hey, server, tell me what changed since then. And the server replies, and what it says is, here are the changes. We're at 616. You will be at 717. These 2 IDs were created, and this one has changed in some way. And then you can decide to do what? Update your cache. What do? Maybe you refetch those messages. Maybe you just invalidate the local storage, but you know how to change your cache. Because just like IMAP, JMAP is a cache management protocol. It's just easier to use. Here's another example. Email query is basically what we call search, when you search your email in IMAP. So we're going to search for mail that's been flagged and that's from me. Really simple. And the response to that will look like this. You did an email query. Here are the IDs that result from that. And the reason that it gives back IDs is it's about managing your cache, right? You should have messages cached. If you don't have these, well, now you can fetch them. But if you did have them, why send you the messages back? You should have a cache with these messages. If you didn't, you would go ahead and say, great, email get these messages. I didn't have them, but I want them, so you get them now. And it works great. It makes sense. You can think about this really easily. But we should talk about IMAP again. So in IMAP, it works the same way. You say, I'm going to search flagged messages, and it says, here they are. And then you say, I'm going to fetch those. Right? Makes sense. Same thing. IMAP and JMAP look the same in a lot of ways. This is what you don't always see in these diagrams, where the round trips come in. Right? First, we search, goes to the server. Server computes the answer, sends it back. Then we say, I need those messages. We say, give me those messages. Send it to the server. Server finds the answer. Server sends it back. You're waiting for the speed of light back and forth twice. That's what happens here too, right? You say, I want to do a query, I get the answer, I look for those messages, it goes to the server again, and it comes back. So the same weights sit here, but you don't have to let them sit here with JMAP. Because when you write your query, you can write this. I want to do a query and a get. And what is the get going to fetch? I don't know the answer yet. That's okay. You tell the server, which IDs do you get? They came from another thing I asked you to do. So get the IDs by looking at A. It should be an email query. Get the IDs out of the response that you compute before you send anything back to me, and do the method call with those. It's called back reference. And you can have a whole bunch of method calls that back reference to one another to let the server do all the work and only do a round trip back to you once. So you get one wait state. Really good. OK, a couple more things. This is a larger section of a JMAP query. I've put in some more things I've been skipping on these slides. Mostly you've been seeing this stuff, actual method calls. But what up here is good too. This is called the using block. It tells you what capabilities you want to use. This one's really simple. If you squint, you can see we're using core, which is like, yeah, I'm speaking JMAP, and mail, which is, again, I'm looking at mail. But you didn't have to squint, apparently. I had to build. But you can have lots of other capabilities. At FastMail, we have contacts and calendars over JMAP. And those are going through the IETF now. There'll be RFCs, and we have lots of other stuff, too. What that means is, if your server supports mail and contacts and calendars and other stuff, when you come back from offline, you can synchronize everything with the same request. Not just the same protocol, but hello, I'm back online. Please get all the changes since my offline state and fetch the updates to me all at once. You can also write your own custom data types for whatever appeals to you, whatever your business needs to use. Add it to your implementation, because even though the data types in JMAP are domain specific, we let you build your own. Anybody can build their own just by describing how those methods will work. I'll talk about it just a little bit. FastMail, we use this for mail filters, so your preferences, your credentials, your DNS, your files, and billing, all kinds of stuff we just do over JMAP because it's great. Okay, getting close to the last things. We also give you event source. Event source is a long-running connection. I'm old enough that I still call it Comet, right? Like you connect to the web server and you say, tell me when things change, and you stay connected, and every once in a while the server sends you a little blob like this, saying, oh, there's an update to your email state. Oh, email and contacts have changed. And when that happens, what does your client do sitting there connected? It invalidates the cache. It can refetch things. It can update the screen immediately. So IMAP has this with something called idle, but CalDAV doesn't, CardDAV doesn't. And when you do this on your mobile phone, idle's not going to help you much, because Apple sure as hell's not letting your phone sit there with a connected TCP stream live to your IMAP server all the time. So people build these interstitial servers instead of getting a web push, which would just directly send your phone a message. And JMAP supports web push. So you could just get real-time updates from all these protocols. So this is our IMAP. We get rid of all the bad stuff, just about, and add all this good stuff. JMAP and HTTP, anybody can use. Avoiding round trips by combining these requests. Putting lots of data types in one place, and real-time synchronization. And the cost is that not everybody's using JMAP yet. It's growing, but it's still pretty early. And there's way too many squiggly braces and double quotes. But like, that's the price I'll pay. Okay, so what now? You want to know how this works. The first thing you should do is go look at this repository, fastmail/JMAP samples. It's code that just does some real basic stuff with JMAP, and you won't understand it yet, but it's going to give you an idea of what JMAP use looks like, its simplest form. Then it's time to read RFCs. Yes. Don't worry, they're actually pretty good RFCs. You should look at these if you want to play with JMAP. The first one is 8620, which is going to tell you what the basic methods are, and then 8621, which tells you the data types. So 20 is going to tell you things like how do you get, how do you set, how do you do changes, just what those are that work on any data type. 8621 is going to tell you the specific data types that we use, like mailbox, thread, email, and so on. Everything else, you just learn more data types in calendars and contacts, basically how the protocol works. You learn the data types on top of the core methods. Some highlights from RFCs. Yeah, okay, I got it. A minute and 18 before questions. Email is the most complicated data type in JMAP for obvious reasons. Emails are big and weird and complicated. JMAP does a great job of making them easy to deal with. Here's an email get. When you do a get, you can also say which parts of the thing do I want to get. Don't get every property, just get pieces. So I might say I want the from, to, subject, preview, like a little snippet you see in your mail client, and it's mailbox IDs. So what do you get back? This. Do I have a build? Great. The to and from come back as structured objects that have parsed the email headers for you. Nice. The subject comes back decoded. That's ASCII, so that was a poor choice of string, right? But it comes back decoded. The preview is decoded. And mailbox ID is this weird set thing. Why is it an object instead of just the one mailbox ID? Because it can be in multiple mailboxes ID. And if you hit me up later, I can tell you about labels mode, which is what we use this for. It's really nice. So the headers, you could fetch the subject, but you could also fetch the header called subject. And when that happens, you get back the quoted printable, the literal thing. But if you want instead, you could say give me the subject, the literal bytes, or give me all the headers, because maybe there's multiple subjects, or all the headers but decode the text. You can get anything like that. You've got no time left. I'll show you this. When you fetch the body, you can get the blob ID. Don't do that. That's how you have to MIME parse it. Instead, you say you want to fetch the text bodies and all their values, and you get something like this. Here's all the bodies you need to display the full text of the message. Like there's no MIME parsing, there's no remembering. What do you do with, you have multi-part alternative and multi-part related? How does that, no, just do that. Okay, yep, time for Q&A. The first thing I will say is you can ask me for more later, use fastmail, blah, blah, blah. How about questions?
All right, thank you, Rick.
Hi.
Hi.
Thank you very much. So one quick question about adoption. Did you reach out to, because when looking at this protocol, and I've been playing around with it for some time now, it looks fairly similar to whatever Google and Microsoft do.
I'm not familiar with those companies.
Yeah. Yeah. So is there any chance that these guys would be interested in adopting this, or?
Yeah. Yes. I mean, I think I can just say that. You can imagine, like, Microsoft, Apple, and Google are all standing around a well in, like, a spaghetti western with their guns at each other, like, who's going to change first?
Right.
Apple's client is by far the most popular mail client in use. Google's servers are the most popular servers. If either one breaks, we're in. And I've spoken with people at these companies, and they're interested, but of course it's a huge amount of work on something that, even though it's clearly technically superior and a big win, is a gamble. It hasn't won yet. I'm pretty optimistic that we're going to see things happen, but I don't have any secret knowledge.
Yeah. Thanks.
Could you pass the mic to Daniel Thoreau? That was faster than I am, probably.
Hi, thanks for the talk. What about JMTP?
Yes, JMTP. Yeah, so replacing server-to-server communication is a much more fraught problem than replacing what your client does. I would. Yeah. So submission. Are you asking about submission? Okay. So mail MTA to MTA, right? Full exchange of mail between different, the Fediverse of email, if you will. That's going to be SMTP, as far as I know, forever. I'd love to see JMTP replace it, whatever the hell that is. But submission, where your mail client says, I want to give this message to be sent, JMAP supports that, and it's really, really good. It has lots of really nice features. It has the ability to tell you, oh, by the way, that mail you sent bounced. It has the ability to tell you how many people has it been sent to. And the way that you create messages as a client author is much, much, much simpler. You don't have to think about constructing MIME bodies yourself. You can just say, here's some attachments, here's the text in HTML, and the server can do everything for you. So it does replace that. It also, because it's one protocol, you're never like, I can fetch mail, but I can't send mail, because one server's up and one server's down. It just always works.
What do you do about encrypted messages?
So you're at like OpenPGP or SMIME sort of things? Yeah. So what do we do about encrypted messages? Punt. Well, so there are some RFCs about SMIME and handling SMIME messages, I think all by Alexi, if not mostly by Alexi, that I would say are optimized for the server having access to your key material, right? Is that a fair way to describe it?
Yes.
Yeah. And there have been discussions about how we would deal with encrypted messages when the server doesn't have your key material and only the client does. We've talked about, it's complicated, and I think there's interesting things we can do. But generally, JMAP is built around the idea that whatever the server can see, you can see. And encryption, as usual, makes things less convenient.
All right. Thank you again very much, Rick. And I think you will be around. And